Hello and welcome back to the channel, and today we're going to take a look at something called Radio Mobile. Our clubs recently talked about various activities we could do, and one of the suggestions that we come up with is fox hunting. And in order to position a fox that's going to be stationary, which is a transmitter that you have to find, we're going to take a look on some software that allows you to predict what areas you will have coverage or not. So today we're going to do this with a program called Radio Mobile. There is actually a downloadable version which is a lot more in depth and consequently harder to use, but there is a simplified version that is online and very easy to use. So today we're going to go through that. So go to your favourite search engine on the internet, type in Radio Mobile, and this website here, ve2dbe.com, this is the one that you want. If we go to the top here, Radio Mobile Online, and I've already put in a dummy account to show this for you, but you would normally set up your own account here by clicking on create a new account, put a username and password in, etc, etc. You then click submit, and you'll come to this screen here. There's several colour coordinated areas, and the first one is a new site, the second is a new link, the third is new coverage, and then antenna types. And from this we can build a picture of what we're trying to do here. So I'm going to go to new site. You get a map of the world, and there's two things you can do here. We can drag the cursor to where we want to be. I'm here in England. You can also click center at cursor, like so. So when you move the cursor, center at cursor will put that in the middle of the screen for you. So if you happen to be off to one side, it will recenter the screen. Or there's place cursor at center. When you do that, it moves the cursor to the center of your current screen. We then zoom in, and on the top left here you'll see there's a zoom in bar. I'll just make this full screen so hopefully it's easier to see. As we zoom in, again we can use place cursor at center to move the cursor, or center at cursor. If we put it off to one side, it would move the screen to the cursor. So one way or the other. Now I'm actually located in Nottingham, so I'm going to pick a couple of random locations here, and I'm going to say that we have, for example, somebody in, where have we got here, Plumtree. Now I know that Plumtree tends to be a bit of a low-lying area, so I'm going to pop this at the junction in Plumtree. Zoom out again. Okay, and this is going to be our first site. So I'm going to click on submit. It gives us the longitude and latitude of that location. We can name it, so I'm going to say test 1. It gives us the elevation above sea level, a description here, so this could be operator 1, and you could put a group in as well if you wanted. And we add this to our sites list. We then make another new site, and I'm going to do pretty much the same thing here. So I'm going to zoom in, center at the cursor. As you can see, that sort of pulls us back up, and we're going to go again, center at cursor, and so on. So this bit's a little bit time consuming, and we're going to pick another location. Now I know for a fact that along this here area in Mapley, it is a hill, a ridge. So I'm going to place it about here. Just again another typical random location. But I do know this is high up, so the two should be able to see each other. I'm going to say this is test 2 and description operator 2. You don't have to put a description in, but I would recommend naming it at least, so that you know where it is in the list of sites. So we've got two sites now. We want to see what the link would be, the RF connection between the two. So we go to new link, and in here we're going to say where the link is starting and finishing. So if we go through the links, and as you can see I've been doing a few already, we want test 1 as the first position, and test 2 as the second. You can add as many as you want. And the antenna height above the ground, so I'm going to say test 1 is probably going to be a house, somebody at home. So I'm going to say 6 meters above the ground is their antenna. And test 2, let's say it's somebody in a car, so their area will probably be about 1.5 meters off the floor. You can change these values to whatever you want though, so it could be 6 and 6, or if somebody has a high antenna you could make it 10, whatever. It could both be mobile stations, in which case 1.5 meters is probably a fair amount. And then let's give this a description, so test 1 to test 2, or you could have it Mapperley to Plumtree, or whatever you want. We can then define what frequency, and I believe this does all VHF and UHF and possibly above that as well. Generally I tend to use this for VHF 2 meters and 70 centimeters around the 430 megahertz. We're going to go for 145 megahertz, which is pretty much the center of the amateur band for the UK. And we're going to say 10 watts. So perhaps this is foundation license holders that are only allowed to use 10 watts. Or it could be that because they're mobile stations, you only want to run 10 watts so you don't wear your battery out quickly. We can then put in the transmission line loss. So 1.5 dB, that's perhaps very reasonable for any typical sort of length of coax, but you can again adjust this to what seems correct for you. The transmitter antenna gain, I'm going to say 3 dB for that, and the receive antenna gain, again I'm going to pick 3 dB, yours might be more or less, but that's perhaps a typical amount for a small aerial. Okay, the receive line loss, 0.5 dB, again you can pick whatever you want with this, but I'm going to leave it as 0.5 dB. And the receive threshold of the radio, now you can look this up in the specs in the owner's manual, and also there's rigpix.com online. They have a lot of the stats for most radios these days, and it's your receive threshold that you're looking for in microvolts. 0.25 is fairly typical for something like a mobile radio that would fit in a car, so I'll leave that as 0.25. Required reliability, now again you can pick whatever you want from this. I've put 90% because if we're going to do a fox hunting event, I really want to be fairly sure that they're going to be able to see each other. In fact, I've just thought I could have put fox and hunter as the two different names. Okay, so 90% reliability, I think that's fair. Use LAN cover, yes. Use 2 rays, yes. Okay. So let's click submit here, and this will do a calculation now, and it bears in mind the contours of the land. Wow, that was quick. And if there's anything, any blockage in the way, as you can see here, there's different colourings implying that there's some sort of blockages, whether that be houses or trees or what have you. And because this is online, I believe it's updated regularly, so it should be fairly accurate. And we can see the lay of the land here. So test 1 in Plumtree is very low down. Test 2 location in Mapperley is very high up, and there's a lot of lumps and bumps in between, but for the most part, as you can see here, this green line indicates that we do have a decent line of sight between the two. There is something called a Fresnel effect as well, which is these curved lines where there is a bit of receiving that you can do even though it's not dead on line of sight, and that's not something for the video today. So if we look through the information here, we've got pictorially a representation of what's happening. On the left we've got the details of test 1, longitude, latitude, ground elevation, antenna height, etc, etc, all the things that we've already predefined. Same with test 2 on the right. And then the radio system itself is described in here. So the transmit power, the line loss, again the information we've put in. On the right we've got the propagation information, and this talks about the losses from the different obstacles in the way. It's saying here that we'd have a total path loss of 128 dB, which is obviously a significant amount, and performance wise we've got the distance, the precision, frequency, etc, etc. So it's very detailed here, and it gives you at the end a fade margin of 34 dB. So this is what it could change by depending on conditions, for example. We then have a map showing the actual link here. So all in all, this is a very, very descriptive and helpful way of looking at a radio link between two stations. We have the received signal in both decibel millivolts and also microvolts, straight microvolts. So very, very detailed. That would be a nice strong signal, considering that your radio can receive a quarter of a microvolt. 13 microvolts is a nice strong signal, so no problems at all there. Okay, it's as simple as that. Now we can actually look into other things here. If we return to the main menu, we can look at coverage as well. So if we click on coverage, we can actually give it a station. So for example, the station that we saw there in Mapperley, this is the higher station. We can describe the attributes of the aerial, whether it's omnidirectional like a white stick or a Yagi, etc. I'm going to leave it as a white stick, omnidirectional, and we can say the coverage is going to be received by what type of setup. So if it's a mobile receiver, it'll be 2 meters in height, and the gain of the aerial there. I'm going to put this as test coverage, just to give it a name so it stands out. Again, the frequency, so we'll go for 145 again, 10 watts. I'm going to keep all the losses, etc. the same. Strong signal margin, so this will be indicated in green, and weak signal will be indicated in red. The opacity of it is basically, are you going to paint strong red over the map, or is it going to be transparent to a degree so you can see what's underneath it? So I think 40% is fairly reasonable. What kind of range it needs to calculate out to, and I think 25 kilometers is plenty. That's 15 miles in every direction, unless you're wanting to cover a huge range, in which case you can increase this. But obviously all it will do is add to the render time for this, and if you're only wanting to talk locally, you're just wasting time waiting for it to render. Rendering can be low resolution, high resolution, etc. Low resolution I've found is more than adequate for most situations. So away we go with it calculating the actual presentation, and we should see a map with red and green areas indicating where there's strong coverage and where there's weak coverage. As you can see at the low resolution, it doesn't take long at all. Okay, nearly there. Alright, so this is what it looks like. As you can see, we've got the radius here of coverage, and we can zoom in, and essentially on 2 meters you have very good coverage of the area. You can see where it transitions to red in various spots, and typically this is where there's lumps and bumps in the topography there blocking the signal. As you can see, if we go down here to the Plumtree area, it's all in green. So somebody at the location up in Mapperley will easily be able to cover all this area. There's a dead zone here, and I believe this is because it's behind a hill, and obviously we're getting worse coverage there. However, when it's in red, it's still got some coverage, but not great. Okay, if we now look at the coverage for the other location, so we go back into new coverage, we're now going to select test 1, which is the Plumtree location, test coverage 2, doesn't really matter, I'm going to delete this afterwards. Okay, 10 watts, click submit, and now we're doing the same for the second location in Plumtree, and our expectation would be, because it's lower and in a bit of a valley, we should be seeing much more restricted coverage rather than the excellent coverage from high up. Again, this is only using 10 watts. There we go. So much more restricted coverage, as you can see. And essentially it's in a basin here, so everything in the basin has a bit of coverage. Everything outside of it is in red. You can see white areas here on the right and breaking in at various places where there's no coverage. So green is strong, red is weak, and the white area there's no coverage. So that just shows you what height does and location. Having seen that, let's go in to this coverage we've just done, and what we're going to do is we're going to, if I can find out where it is, no, let's go and do the same again. I might not have saved it. We're going to do the same again, however this time we're going to change it to, let's see, 145. We're going to use 50 watts. So you'd think perhaps, is it 5 times better? Is it just significantly better? Is it not better at all? So we'll just test this out. So we're having the same height, same location, just 5 times the amount of power. And as you may know, if you are looking at a receiver on a radio that gives you a signal strength, one S unit, going from S6 to S7 for example, requires 4 times the power to increase from one S point to the next. So essentially we're going up 1 S point plus a bit more. And as you'll see in a minute from the results, generally, as you can see, I'd say it has filled in slightly. I think possibly fractionally better, but very minor difference here. Very minor difference. So increasing the power significantly generally does not help the coverage at all. What we can do now actually is modify this coverage. That's what I should have clicked on last time. And instead of being 6 meters high, if we did it 10 meters high, and let's go back to 10 watts. Now, I haven't tried this out yet, but I imagine going higher will probably give a better performance than just increasing the power. But we'll see. We'll check this out. This is the great thing about this software. If you have a particular location, you can play with the numbers, changing the power and changing the location height, and see which works out better. And generally I've found 99 times out of 100 increasing the height far outweighs increasing the power. Clearly, if you're in a bit of a valley, if you can move the location to a much higher location, that massively helps as well. So here we go. And again, even with that actually, it's not made such a big improvement. So this is back at the 10 watts, but increasing the height of the antenna by 4 meters, from 6 meters to 10 meters. And again, it's because it's in such a valley compared to the outer lying areas, that hasn't made a difference either. So this would not be a good location to pick if you were trying to make contact with a wide area. A better solution would be to put it on a high ridge as we did on the other test, and that will give much better coverage. So I hope this has been of use to you. I'll just mention briefly the antenna types. You can upload different types, different things like the gain and the directionality, etc. But they have these basic ones here: an ellipse, cardio and a Yagi. You can draw the antenna pattern and it will give you an idea of the direction and the strength of what the aerial does. And as you can see, this Yagi has a main lobe there, very directional, horizontal lobes that are quite strong, and then 2 minor lobes at the bottom going backwards. So again, if you're using a Yagi antenna, this is a fairly decent approximation of perhaps what your Yagi would do. You can modify and upload other radiation patterns, and again it will calculate it all out depending on what you've put in. So I hope this is of help to you. Please like, share and subscribe to the channel, and if you have any questions or comments, please add them to the bottom of the video. Thanks very much, and see you next time.